Hello everyone. In this video, I would like to discuss how can we use Siemens S7-1200 PLC to read the sensor or read the incremental encoder for counting the signals from the sensor or incremental encoder, so we can measure the speed or measure the distance. This is a very common case if you are developing one packaging machine or conveyor or some very simple distance or speed measurement system. One typical case as shown in this picture, we can use the regular sensor detect the pulse from this roller. Maybe this roller has one pulse, one revolution, maybe 100 pulses, one revolution. Or a little bit higher end that you can use the incremental encoder. The incremental encoder mounted on the shaft. For example, if you are using 1000 lines of that incremental encoder, that means 1000 counters represent one revolution. So if you receive 1000 counters from this channel, the high pulses channel, that means the roller run one revolution, right? So in this case, I would like to show how can we implement this. If you already have some basic knowledge on Siemens S7-1200 PLC, probably you can read this application example that from this number 109742.346. And from this application example, it includes 3 examples for counting the speed or counting the distance for that, which is very useful. So you can download the manual or download this project. And in this video, I will start from the scratch to explain how can we use the HSC, these resources of this controller, so we can read the counter from that ID 1000 channel. So we can read the counter, and after we got the counter, we can do a little bit simple math, manually program how can we translate this counter to revolution per second or RPM, revolution per minute. Before we start, I would like to explain the basic knowledge of this incremental encoder for the new learner. Probably you can browse the Wikipedia to search the incremental encoder and read the detail on this page. So the basic idea of this incremental encoder, it has multiple lines here. And per revolution of this encoder, it might give you hundreds or maybe 1000 or maybe higher resolution. The common resolutions from the incremental encoder in industry world, they're probably from 200 lines to 4000 lines per revolution. Therefore, if your incremental encoder mounted on the shaft, and if your shaft run one revolution, so that means you will get 200 pulses or 4000 pulses, depends on the incremental encoder resolution you are using. If you are using the common incremental encoder, so the basic channel from the incremental encoder, it can give you A and B 2 channels. The 2 channels actually run like this. To count the actual signals, one channel that's enough. So we can use this rising edge to count how many counters from this signal. The reason why we are using 2 channels, usually the incremental encoder give us 2 channels. One thing that A and B can give us a direction. So if A behind B, maybe that represent the forward. If the A at the left side of the B, the system will know you are doing the reverse. Another thing that is this quadrature output. For some system, when it's counting the incremental encoder, actually for one pulse, it separates 4 pulses inside. You can imagine for this small area, it actually count this rising edge, this flag, and this rising edge, and this area. So one pulse before, now it actually count 4 times for that. So it depends on the quadrature setting from your reader, the incremental encoder reader. In the Siemens S7-1200, the channel, when we configure the channel, it also have this quadrature setting. But usually, if your system do not need that high resolution, so probably you just select the normal way. That means your incremental encoder reader will use the rising edge to count the counter and use A and B judge the direction. You do not need to select this quadrature setting. It depends on your system resolution you need. Okay, so this is the basic idea for the incremental encoder. You can read the detail on this page. In this test system, I'm using Siemens S7-1200, this CPU 1211, this small controller. and it's pretty small. And from the input of this controller here, I'm using A and B from the incremental encoder connect to the input channel 0 and 1. That is the A and B from the incremental encoder. And the incremental encoder I'm using, that's the back of this incremental encoder. It has 1024 lines per revolution. And this incremental encoder mounted on this DC motor shaft here. And from this gearbox, so the DC motor run a slower speed, that is a 150 RPM speed. And I can use the analog output, use this module to control the speed of this motor. And in this test, I will run this shaft basically 1 revolution per second, so we can verify after we read the incremental encoder calculated value, then showing the revolution per second should show around 1. So this is the basic idea for this test. Alright, let's go to Siemens system TI portal. Let me show how can we configure using Siemens S7-1200 PLC and read the incremental encoder value. And in my TI portal project, I'm using S7-1200, so my controller is here. So even this is a very low-end controller, we know this is 11, the lower number on here, the lower performance, but it still have a 6 high-process counters resources in this controller. Okay, once we set up the hardware, we drag this controller at here from the right side, this device overview. From here, you can see the system will automatically assign the address and show the resources from this controller. HSC, this is a high pass counter. The first one is start from the 1000 and till 6. That means this controller give us 6 resources. To check the resources for your controller and check out what the high speed these resources can do, we can find the Siemens S7-1200 PLC system menu. And then if you go to the chapter 1.1, here it shows high-speed counters. We can see for my system 1211C, it has 6 resources inside and it can take 100k Hz, which is very fast. So, and this is built-in, you do not need to purchase any additional hardware. And in this case, I will use this resources 1, HSC_1, and our address will start from 1000. When we read the data from these resources, that come from the ID 1000. ID means the D, that is a double word that includes 4 bytes. So that's why it comes from 0, 1, 2, 3. So 4 bytes here. For reading the channel, it named ID 1000. I will show how can we use this after. Let's go to the system hardware properties. Double click this controller. Let's go to the High-Speed Counter HSC, this page. We can pick the resources one. Actually, you can pick one of them. It doesn't matter because if flexible, we can configure which hardware channel belongs to which resources. This just represents the resources. Okay, so we can pick the number 1 and check this enable. Okay, we enable these resources. Okay, we enable this. And the type of the counting. So it includes 4 modes: counter, period, frequency, and the motion control. And regarding this motion control, I used another video showing how can we use the incremental encoder as the position feedback. And the positioning axis, the technology object here, we can configure the motion control, use this high-pass counter to read the incremental encoder. But for the simple case, most of cases we will select the counter. Personally, I would recommend we select the counter even you are doing the frequent or period counting, because you can imagine once you got a counter, you can calculate everything you want for the frequency, for the period, or for the distance. But once you select the frequency, and after that, in case you need to use the frequency translate to distance, that's a little bit hard. But for the counter, that's very fundamental. Once you got a counter, you can do everything else. I will use the next video to show once we receive the counter and how can we use the counter to calculate the speed of the motor. Translate from the counter to the speed, revolution per second. In this video, we mainly focus on how can we read the incremental encoder, read the counter into the PLC. And here, the operation phase. This is very important. If you are using the very simple sensor, just a 1-channel sensor, so you can select this a single phase. For example, for one revolution, maybe you count 10 pulses. You can select this single phase. But in this case, I'm using the incremental encoder. So I need to select this AB counter. So this AB counter, I need to use the two channels. The one channel is A, one channel is B. So I can use this two channel to know which direction is running, positive or negative. And this 4/4, that is for the cordial mode. So most of the cases, we will select this AB counter. Okay? And initial counting direction, that count up or count down. Initially, we can select this count up. If you find once you set up system and once this motor start to run and you found this direction go reverse, then you can pick this count down. And here it shows initial counter and high limit, low limit. Basically, we will leave all those as default. If you do need change the preset value or comparison value, we can use the program to set those value. I will show how can we call the program after. And the reference value, that's also an important value. Most of cases we will use that. Some cases, if you want to compare the counter to represent this roller reach to some certain distance, and then you need to call the interrupt, and using the interrupt control the signal, turn it on or do something. So we will call the event trigger. I will explain this very shortly. And for those synchronous input, capture input, and gate input, you can read the detail from the S7-1200 that manual. Also, you can read the application example. From this example 2 and 3 is using the hardware gate. So it explained how can we use the capture and gate input. Okay. One important setting here, that is this event configuration, as I introduced from the reference value here. So probably you can set a very high value that represent maybe 10 revolutions or maybe a certain distance for that once it comes there. So that time you need to output one thing. So you can use this event configuration. You can turn it on and you can see here. This event configuration represents the counter value equal to the reference value 0. That means once you set a certain value at here, this reference value. So once the counter reach there, it can output one thing. So which channel you want to output? Here, we can let the system call the hardware interrupt. So for example, if I add one hardware interrupt here, so we can call this 40, okay? So keep in mind here, it can generate one thing. If I click OK, so the system will generate this OB40 hardware interrupt. And then we can go back here. So we can see the system generate this hardware interrupt. This is that name. And its priority is higher than the OB1, the main cyclic organization block. So that means once the system count up and count reach this value, reference value, it can automatically call this hardware interrupt. And in this interrupt OB40, you can do the logic here or control the output. For example, you can fire the nozzle or you can fire the printer to turn on the tools. So this comparison event, this interrupt is much faster than the normal logic. You do the counter data comparison. Okay, this is the event configuration. And then we can come here, the hardware input. Here that represent which hardware channel we can assign for this high-speed counter resources. For the resources 1, we can use the channel 0 and 1. The input 0.0 is for channel A, and channel B, we can connect to the 0.1. We can see the highest frequency from this hardware, that is 100 kHz. Okay, here we assign the hardware channel. And after assign here, we need to keep in mind one thing. This 0.0 and 0.1. Let's go to here. Still under the CPU properties, go to the digital input here, the channel 0 and the channel 1. They are 0.0 and 0.1. So from here, keep in mind one thing. The channel, this input filter, the system will automatically assign the filter at here. Keep in mind, probably by default, some cases, the filter would be assigned as 0.1 milliseconds here. it depends on the noise from the incremental encoder signals. The system will automatically will select 0.1 milliseconds, which is here. So there's one reference table from S7-1200 manual. If we go to chapter 6.6, configuring the operation of the CPU, from this list, it shows, so basically this is recommend input filter time. If you are using the 100 kHz, the filter time you need to set below 0.8 microseconds. Probably we can follow this 3.2. So if we go back to the TI portal, keep in mind this is a micro. This area, this is million seconds. So here, this is very low. So we can select 3.2 or lower than this. So probably we can pick the 0.8 microsecond. This is a millisecond. Then they found, so this is channel 1. We will set 0.8 microsecond. We done the configuration. We set this filter. Also, we active this hypothesis 1. And we pick the hardware channel 0.0 and 0.1 for these resources. And also, we config this type, this is counter, and its mode is A and B counter for reading my incremental encoder. Okay, let's download this hardware controller. Okay, let's start the controller. To read this input, so we can open the OB1 and we can use very simple logic. For example, let's use this move. The signal, the counter, come from the channel 1000. To read this 1000 channel, we will type in ID 1000. Okay, this is the word. We can copy this value to an internal variable. For example, for the 1200, we can, to use the internal memory, we can use MD 1000. Okay, and define this channel as the integer. Okay, we can go to the PLC tag and open all tags. And here, this ID 1000, this is our HSC underscore the 1. This is the incremental encoder channel. We can call it INC. And for the incremental data here, this data type we can switch to the dent, double integer. Okay, once we got the integer, we can calculate. And this channel, we can call that, so our incremental encoder counter. Okay, now we can download this program. So we can click this download. Now we just boot up this PLC. So initial value, it shows 0. If I manually spin this motor, and meantime we can watch this input I 0.0 and I 0.1. And now if I spin this motor, so we can see this 2 channel is flashing. So means it's reading something there. Okay. And in the meantime we can see this value channel is changing there. And my incremental encoder, that's the 1024 lines per revolution. So now if I spin this motor, we can see the counter value from this channel. And I will run the motor roughly around 1 revolution, 1 second. Okay, so now I will start this motor. So as we can see, this counter is increasing. And also we can see when the motor runs in this direction, this is CCW direction. So my counter is increasing. That means this is now the positive direction from this channel. If you find your motion direction and your encoder, the counting direction that go reverse, so you can go to the properties of this CPU and change this count up to count down, or just go reverse that setting. And keep in mind, while we are using the AB counter, AB encoder here, we cannot use the program to change the direction. The only way to change this direction, that is using this CPU properties. And after we change, we need to download the CPU properties. And if you use the normal sensor, so while you are selecting the single phase, then you can use the program to switch direction, because that direction can be controlled one digital input or the math logic behind. Now we can read the data or read the counter value from this two channel, input 0.0 and the input 0.1, that HSC, the resources number 1. However, so far we cannot control, or especially some cases we need to initialize the value. So how can we control that? How can we use the program to preset the value on this counter? Then we need to use the program. We need to call the function control underscore HSC. As we can see, we have a two function block here. I will drag them out and we can do a very simple comparison. So for this EXT, I can name that 10. And for this simple HSC, I can drag to here, named 11. We can let the system automatically generate this instant DB. So we can see the EXT shows very simple, looks simple, but actually if you need to use that, you need to create one structure UDT. And inside the UDT, there's one structure, and then you can use that. But for this simple control underscore HSC, this is the original legacy one. Its output and input, they all here. So it's quite straightforward. Personally, I would recommend you can use this legacy one. For the new learner, it's very straightforward. And how can we use this EXT? Again, you can go back to the Siemens application. This application is using this HSC EXT. And it covers these three applications, basically cover 90% scenarios. So if you do need this EXT, you can directly use the function block from this application example. You do not need to develop by yourself, start from the scratch. You just directly use this example. Okay. And for the simple use, we can use this legacy one. That's enough. Okay. I will delete this new one. And to use this HSC, so this HSC, this function block is used for switching the direction or set some comparison counter. That's enough. This is the functionalities of this function block. Okay. And to allow this HSC function block to know which channel, which resources is controlling, so we can use this job list and we can browse the HSC channel 1 here, the local HSC channel 1. This is that resources channel 1. And here we can set the direction control command. For example, here we can use our internal memory 100.0. Okay, this is the direction. So we can name this tag. We can name that DIR in. And the actual direction, the setting that comes from here. Keep in mind, this is an int. This is integer. So we can use MW102. So this is a new direction value. Okay. And for the CV and RV, you can read the help from this function block. We can click F1. So here it shows CV and RV, what does it mean of them. Okay. And please look at this detail. Okay, this is the direction, but actually in this case, this direction setting won't work. That's because in the hardware configuration at here, the counting direction specified here that turns gray. That means we cannot use the program to change the direction. We can only use this count up and count down to switch this direction. This is a special case I would like to mention because some people would like to use this change direction using the program to switch the counter direction. But once you use the A and B counter, it doesn't allow you to do this. If you use the single sensor, for example, the single phase, so then you can see this direction selection, use program internal direction control. But once you select this AB counter, so the system will automatically switch to this mode, the external mode. It doesn't allow you to use the program to switch this counting direction. So you can pick the count up and count down. But basically, once you run one time, you will figure out which direction that is the positive direction you need to run. Okay? And other than this direction, I will also program for setting the preset value. For example, if I program here, this is CV enable. And we can prepare the new CV value here. Keep in mind, this new CV, that is the dent, the double integer. So when we use this, we need to use MD 104. Okay, we can name that new CV. Then let me go to the PLC variable list, double check the date type. Okay, we can name this new CV. And now we can download. And after the download, we can see the initial value that is 0. So now we can preset this value, this counter value. If we go to this new CV here, and if I set, for example, 1000, prepare the 1000 value here and trigger this CV, turn this on. And in the meantime, we can see the output BZ here, it doesn't show any fault. And then we can go back to the counter. So we can see the counter preset 1000. This function is very useful, especially for some cases you need to retain the incremental encoder value. For example, you can write the incremental encoder value to a retained DB. And after the system restart, you can load the retained incremental encoder value to this new CV here. And load the value, retain the value at here, and in the meantime trigger this CV. And then this incremental encoder value channel can be loaded from that retained value. This is a very common way to use this CV to retain the incremental encoder value to this channel back. And now if I turn on the motor, and then go back here, we can see this counter is counting up. Alright, this is a brief demonstration to show how can we implement the high pulse, the HSC, the high pulse function for reading the incremental encoder using the Siemens S7-1200 PLC. We are using the built-in two inputs, digital inputs, I0.0 and I0.1, and use the HSC_1, the first resources of this high pulse counter. And now we can read the counter. And how can we translate the counter to the resolution per minute or resolution per second? This is the rotary speed. Usually we can use this speed represent the conveyor speed and the motor running RPM, right? And we definitely need the counter, some calculation way. Some cases we can use the properties setting to do this, but personally I recommend we can use the counter, use the mathematical way to program some simple logic to translate this. That allows us to do something very flexible using the counter only. So let's temporarily park here. In the next video, I will show how can we implement this math, the simple math, to translate this counter to motor speed. Alright, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.